did it last week. Okay. See, are you going to send something in the chat window to me, or are you going to verbalize problems? What are we going to do here?
We should be able to verbalize problems. We're working on ratios now.
Okay.
1 second. I'm just going to sharpen my pencil.
Okay.
Okay. Okay, so I have a worksheet and we're working with ratios.
Okay.
So 12, it's find the product and then list the units, and with the first three, she wants us to just get one number, and so it's 12H times $5 over H. So 12 hours times $5 over H.
Okay, what she really means here is this is $5 per hour.
Yeah, that's what I mean.
If you're working at a job and you're getting paid $5 per hour and you multiply by 12 hours, the hours cancel, the units cancel, so your final answer is in dollars, $60.
Yeah, so pretty much you're saying how much money do you get if you work for $12 and you get $5 an hour?
If you work for 12 hours at $5 an hour, right? Exactly. But the units always have to make sense. In other words, you're always going to end up with dollars here. I would not want to ever divide this by $5 per hour. In other words, let's say I made a mistake and thought I had to divide it by $5 per hour. Well, notice the units don't cancel if I do that. Dollars per hour, if I flip the bottom and multiply, I end up with 12 hours times 1/5 with the hours in the numerator and the dollars down here. So nothing cancels. I don't get dollars as an answer. I get hours squared divided by dollars, and that's not what you want. So frequently you can use the units to determine whether you're doing it correctly, if you're multiplying or dividing properly.
Yeah, Ms. Watson says that we should always have something to cross-reduce.
Yes.
So in this case, it's cross-reducing the hours.
Right. Okay, what else you got?
So next one is 6 ounces times 59 cents to an ounce.
59 cents per ounce. In other words, this store charges 59 cents for every ounce that you buy. So that's the way I would write that, is cents per ounce. Per means division, means the division sign. So
you get rid of the ounces, and then you do 6 times 0.59, since it's $0.59, and you get $3.52.
$3.54?
Yeah.
Okay.
So you also get 9.
Now let's go back to that one 1 second. Actually, what I got was 354 cents.
Yeah, but you get $3.54.
Right, because 354 pennies is the same as $3.54. In other words, the moment I convert it to dollars, I have to divide this by 100, because I'm dividing it by 100 cents per dollar. Let's look at that for a moment. That might be useful for you. In other words, I had 354 cents was my answer. But if I want to put it in dollars, well, what do I know? I know that I can multiply that by how many dollars per cent? Well, we have $1 per 100 cents. So the cents cancel, and I end up with $3.54. So in that problem, I really kind of had to do it too. I had two different ratios that I had to use.
Yeah.
Converting it to cents and then converting it to dollars. Okay.
9 hours times 70 miles per hour.
That can be written MPH, but what it really means, remember the per is the fraction sign.
So, yeah. And so the hours cancel each other out, and then you multiply 9 by 70, and you get 630 miles.
There you go. Those are pretty straightforward.
And so,
how many inches are in a mile?
What?
How many inches are in a mile?
Inches in a mile?
Uh-huh.
Inches in a mile?
I'm going to show you how to do it.
Well, there's 5,280 feet per mile, and you
Okay,
multiply that by
so
12.
we can always multiply by 5,280 feet per mile. That cancels out the mile. But to get it in inches, we got to also multiply by 12 inches per foot. And notice that the miles cancel, the feet cancel, and my answer is in inches. So 12 times 5280 is the number of inches that are in a mile. So whenever you're converting units, as long as you know the conversion factor, know that you have to do it in a way. In other words, if you're not sure whether to divide by 5280 or multiply, notice that this told me which to do. I didn't want to divide by 5280 because the miles wouldn't cancel if I do that. Only if I multiply by 5280 will the miles cancel. And then I got to cancel the feet. And I know there's 12 inches per foot, so I got to multiply by 12. I don't divide by 12, I multiply in order to get those units to cancel. All right, what was the next problem you were going to give me?
So these new ones are write the ratio as a fraction in its simplest form.
Okay.
So 12 to 15.
What was that phone number again? Let me call it. I'm starting to get some audio crackle.
Yeah, not getting too well.
Yeah, this will be easy. You don't even need to log off a GoToMeeting. You might have to change the option to use the telephone instead of mic and speakers.
Yeah.
What's the phone number again?
Here, I just texted it to you.
Okay. Text to it? Really?
Yeah.
Oh, there it just came in. I thought texts were more immediate than that. That only took a couple seconds. I shouldn't expect technology to be perfect. Wow, they have Google Camera now? So is search by image. Okay, let's see.
Yeah.
I want, where the heck is my Gmail? Usually that's right up front and center. Okay, so I want Google Phone. Hold on a second. Call phone. And let me put in that number. 303, and it should have it in there from before. Huh, it doesn't. 9330022?
Yeah.
9330022. That is a strange phone number.
Hello.
Hi. Okay, on your go to meeting, go ahead and switch the audio to telephone.
Okay.
Okay? Now that should be better.
Yes.
Okay, good. We'll just maybe do that all the time from now on. Okay, let's see. Go ahead, and you were reading that last problem and I wasn't able to quite understand it. So.
Okay, so write the ratio as a fraction in its simplest form.
Okay.
Have 12 to 5. No, sorry, 12 to 15.
I was going to say, that is in the simplest form.
Yeah.
Okay.
And so then both of them can be divided by 3 and
Okay.
get percent.
Okay. Good.
The next one is 24 over 9. And these can be reduced by 3 again. You get 8 over 3.
Okay.
And the next number is 2 1/3. No, 2 2/3. Okay, so anyways.
Oh, are you supposed to convert it to mixed numbers?
No.
Okay.
Just, I just like to do it, I guess.
It's not always the best thing to do, because sometimes, let's take the number 9/4. If I convert that to a mixed number, 2 1/4, would you know what the square root of 2 1/4 is? Probably not. But do you know what the square root of 9/4 is?
No.
Take the square root of the numerator, square root of the denominator, you get 3/2. In other words, leaving it as a improper fraction is sometimes more helpful for whatever the next step is. It depends on the next step, but it's not always. It's kind of like, do you leave stuff factored or not? You know, is this a better answer or is this a better answer? Well, they're the same thing, but I actually prefer the answer in factored form because a lot of times the next step may require me to factor it, and if it's already factored, I'm halfway there. So
I always do the answers for it, but only when I get the answer do I do it.
okay.
But I just always felt like
I understand why you do that, for sure.
Yeah.
I mean, you don't go to a lumber yard and say, I want 73, or I want 72/12 inches, or I want 72/12 feet of wood.
Yeah.
You go and you say, I want 6 feet and 1/4 inch of wood, or whatever. So in real life, we do tend to convert stuff to mixed numbers, but in mathematics, depending on what the next step to follow is, you might want to leave it in that improper fraction. All right, what else you got?
Our next problem is you have 14 tetras and 6 anglefish. So 14 to 6.
What was the first word? Tetras?
Tetras. So, let me.
Okay.
Yeah.
So reduce that fraction.
What was that?
So we need to reduce this fraction, simplify it.
Yeah. And so you get divided by 2, 7 tetras, and 3 angelfish.
So one could say 7 tetras per 3 angelfish.
Yeah.
In other words, you can substitute per for that horizontal fractional line. When you have units like that.
Yeah.
In other words, you wouldn't want to say 3 per 4.
Yeah.
That doesn't, people aren't going to know what you're talking about if you do that. But if you have 3 miles per hour, then they would. In other words, with units, the per means fraction.
So, and then the next one is find the unit rate.
Okay.
And unit rates are when the denominator is 1.
Right.
So you get 360 miles in 6 hours. So 360 to 6. And then you can divide by the numerator, and you get 60 miles per hour.
Right. And the 1 is presumed there. You don't need to write it in. In other words, the units stay the same. You don't lose in the units.
So the next one is 18 bowlers on 6 lanes. On 6 lanes. Both are divisible by 6 again. And then, so you get 3 bowlers per lane.
Okay.
Next is $28 for 7 people.
I got a feeling you're not being challenged enough, David.
Yeah. Ratios are kind of easy. And Mrs. Boston doesn't she knows what she's going to do.
Uh-huh.
Like, she knows the units that we're going to do, but she doesn't know exactly what we're going to do.
Right.
She can't give me more material.
Right. No, I understand. The problem is that you're not taking a high enough level math for your capabilities.
Yeah.
You're a smart kid, and you need to be taking more complicated math. This is too easy for you.
When we took the test for algebra, algebra,
Yeah.
concussion that day, I missed the test. And I didn't get into the algebra.
Okay.
But by next year, if I get all B's and A's in math, I will go into algebra.
Automatically, without having to take a test?
Yeah.
Okay, good. I'd hate to see you not take algebra last year. I wish you'd have taken the test, because you should be taking algebra this year.
Yeah, I know.
And it actually makes a difference, because if you were taking algebra this year, you'd take geometry next year, then you'd be taking algebra 2 as a freshman in high school,
Yeah,
which is that's fast track, and they even offer honors algebra 2, which is what your sister's taking.
I got so angry when I found out that I didn't get to take it.
Yeah. Yeah. But that's all right. We'll work with what we've got here. So what do I do with this problem? $20 per 7 people.
28.
Oh, gosh. And here I thought we had a hard problem for a moment.
Yeah.
Okay, so what is that?
You divide both by 7, and you get $4 per person.
Okay, now let's change the problem. We'll make it a little harder. If you went out to a meal and you had 7 people and they all decided they were going to pay equally, and the bill came to $20 for the 7 people, how much is it per person?
Well, so you have to do long division.
Okay.
Well, not necessarily long, but division. And that's what I'm doing right now.
Okay.
6. It always is so long.
Just give me the first, to the accuracy to the second decimal point, because that's pennies.
2.85.
Okay, so it's 2.85 per one person. So even if these don't divide evenly by a number, you can still convert it to a unit rate. In other words, every person at that dinner needs to shell out $2.85, and in it all total, it will come to $20 and pay the bill.
Yeah.
Okay?
That's a pretty good deal.
Yeah, that's a cheap meal there. That's less than the McDonald's. That must be Long John Silver's or something. I don't know. That's about the cheapest fast food place I can think of. Taco Bell, maybe? Okay, what else you got?
So the next one is use a table to find the rate, and the table is, should I write it down in the chat bar? Because it makes it easier. I'll do that.
I'm not sure that it will be easier for you to write it in the chat bar, a table, unless I can click on it. Can I click on it and I'll see it? I don't think so.
Should I scan it?
No, you don't. Let's not go to all that trouble. How many entries are in the table?
So on the top is minutes, and it's a table from left to right. But that's okay. So
Where's minute? How many rows are in this table?
just do.
Just 2?
Yeah.
And how many columns?
There is, including the labels,
Uh-huh.
there is 5.
Okay.
So
That's minutes there.
yeah.
What's
On
this?
the bottom it's lap.
What is the word?
Lap. LAPS.
Okay, so we're swimming,
Or running maybe.
I suppose. Yes, you're right. No, that's right. Okay, so what goes in these 4 columns?
So 0, 2, 4, 6, and then 0, 1, 2, 3.
Okay, and what's the question?
Use the table to find the rate. And that one's actually really easy.
Okay,
It always does that. Anyway, it's
so what's the answer?
0.5 laps to every minute.
Right. Or 2 minutes per lap. In other words, you can do it 2 ways. 2 minutes per lap is correct. And it's also, that's the same thing as 0.5 laps per minute. And usually when you have ratios with a time element in them, you do put the time on the bottom. So this is probably the answer she's looking for.
Yeah.
But this is also true. Notice that the only difference between this two is I've flipped the units. Well, when you flip the units, you got to do the reciprocal of the number. So to turn 2 minutes per lap into 1/2 laps per minute, I take the reciprocal of 2, which is 1/2.
Yeah. There was actually a question in the homework last night that asked, in your class, the ratio of boys to, are these statements equal to each other? And it said the ratio of boys to girls are 3 to 2, and the ratios of girls to boys are 2 to 3.
Okay.
And like when you look at it closely, they're completely different ratios.
Right. Right.
It's like saying on this problem, 2 laps per minute.
Oh, okay. Well, yeah, which would be wrong. Yes. In other words, it wasn't 2 laps per minute. It was a half a lap per minute.
So then the first one is, then the next one is serving on the top. There's 5 columns again. And it's left to right. And it goes 0, 1, 2, 3. Next, and then on the bottom it's grams of protein. It goes 0, 15, 30, 45.
Okay.
And then Miss Watson always says that the top is usually X and the bottom is usually Y, and then you put X on the bottom and then Y on the top.
Okay. So we're looking for grams per serving.
Yeah.
And that makes sense because that's what you want to know when you're eating something. You don't want to know how many servings per... I don't want to know that there's 2 servings per 30 grams. I want to know how many grams per serving when I'm eating. I want to know how many grams of protein I'm getting. So what's the ratio here?
Well, 15 grams per serving.
And we didn't even need those other 2 columns.
Yeah.
Didn't need that or that. They're always going to be in that same ratio. Except this is not the same ratio. We couldn't have solved it using that first column only.
Yeah.
Kind of odd, huh?
That would make it be completely equal.
Yeah, well, no, not really. Believe it or not, 0 over 0 is a very interesting mathematical question. That is called the indeterminate. I'm going to give you higher math whether you're taking it yet or not.
Oh yeah, isn't that when...
We don't know what 0 over 0 is. Let's talk about zeros for a moment.
Yeah, if you divide a number by 0...
That's infinity.
Yeah, it's...
Which is also called undefined.
Yeah, scientists can't decide if it's undefined.
Undefined is not the same thing as indeterminate. Okay? Let's talk about that for a moment.
Isn't it that scientists can't decide if it's infinite or just 0?
No, it's not 0. It's not ever 0. There's a huge difference between infinity and 0. On a number line, here's 0. Infinity is as far out from 0 as you can possibly get. Here, let's look at it a different way. Let me teach you this. This is good to know. What is 3 divided by 1?
3.
What is 3 divided by 0.1?
0.3?
No.
Oh, no. 3.
Gets bigger. What is 3 divided by 0.01?
300.
So what is 3 divided by 1 times 10 to the negative 15th power? It's 3 with 15 zeros after it.
Well.
In other words, as the denominator approaches 0, as it gets closer and closer to 0, the result gets bigger and bigger. So when we actually do divide by 0, that's infinity. Now scientists don't like to use the word infinity until you get to be in high school because it's not actually a number, it's a concept. It means large without bound. That's what infinity means. And so instead of saying this is equal to infinity, they've said it's undefined, which means the same thing as infinity. Okay? Now, if I take 0 and divide it by 3, that's equal to 0. That's not undefined. That's equal to 0. So we know what 0 divided by a number is. We know what a number divided by 0 is. The thing that gives us problems is when we have 0 divided by 0. That's called indeterminate, meaning we can't determine what it is without more effort. So this is, we don't know what that is. It depends on how we got there. It depends on the function we were looking at. And it's got to do with limits and everything else. You're still 3 years away from that kind of math. But that's my higher math contribution for today for you.
Okay.
What else do you got?
We have at 9 a.m. you have run 12 miles. At 9:24 a.m. you have run 15 miles. What is your running rate in minutes per mile?
Okay. How are we going to do this? In minutes per mile or miles per minute? They want it in minutes per mile?
Yeah, no,
Usually the time goes underneath.
it said minutes per mile.
Okay, whatever they ask for, that's what we'll give them. So how many minutes have we run?
We've run 24 minutes, but it's only 2 and not. It's only 2 and 5 and not 12 and 15.
Well,
I might have said that wrong. Sorry.
no, that's okay. Doesn't actually matter. Because how many miles did we run in 24 minutes?
We ran 3 miles.
Okay, see why it didn't matter? We were going to get 3 miles no matter what in the bottom. So, what's this equal to?
It's equal to, you would get 8 minutes per mile.
You ever tried to run a mile?
That's really fast.
It's pretty fast, yeah. I mean, that's not real fast. I'll bet you could, I don't know, you probably have to be, in some training to run long distance, but I would guess you could probably run an 8-minute mile.
Yeah. We had one in 6th grade.
Did you? Did you try running? You ran the mile?
In 6th grade, I used to be actually pretty short, and I got 10 minutes in a mile.
10 minutes per mile? That's probably pretty average. I mean, an 8-minute mile is probably fast if you're running a marathon. If you're running for 26 miles and you're averaging 8 minutes per mile, you're doing pretty good, I think. Obviously, the world record for the mile, do you have any idea what that is?
No.
3 minutes and I think it's 3 minutes and about 41 seconds per mile. That's the world record. And 100 years ago, nobody in history had ever broken 4 minutes. In 1954, the very first person in the world ran a sub-4-minute mile. Since then, they've continued to take seconds off the record, and now they've taken almost 20 seconds off the record in the last 50 years. That's how much better training is, and conditioning, and everything else. Well, now there was a case where the time did not go in the denominator, but we could have. In other words, we could have made it 3 miles per 24 minutes. Well, now I got to divide. If I divide everything by 3, I get 1 mile per 8 minutes. That's pretty good. That's the same ratio we got. It's just stated differently. The other one was 8 minutes per mile. Well, this is 1 mile per 8 minutes. But if I wanted to know how far I'd run per minute, I would want to divide top and bottom by 8. So I would end up with 1/8 mile per minute, which is actually the more standard way of writing speed, is you put the distance on top and the time on the bottom.
That actually makes a lot of sense.
Yeah, miles per hour, feet per second. If you talk about the speed of light, you talk about it moving in feet per second. Or miles per hour is 60 miles per hour is 88 feet per second. So we're usually, whenever we're referring to speeds, we usually give the distance on top and the time on the bottom. But on that last question, she asked you for minutes per mile, which is perfectly fine and acceptable. So we did it that way. There's no real standard. You know, it's whatever she asks for.
Yeah.
Okay, what else you got?
There are 234 students in 9 different classes. What is the ratio of students in the class?
Okay. Is that thing divisible by 9?
Let's check.
Hold on, before you check. You know how you can tell if a number is divisible by 9?
It adds up to 9.
The digits add up to 9. 2 plus 3 plus 4 adds to 9. So any number whose digits add up to 9, for example, this number, that's divisible by 9. Because 1 plus 8 add to 9.
Weird.
Just a nice little trick worth knowing, because then you know that this can be reduced. In other words, if you know this is divisible by 9, it's helpful. If you're trying to reduce this fraction to something, it's nice to know that that's divisible by 9. So what is that? 26?
26.
Students per classroom. Bless you.
So the next one is dishwasher detergent is sold in individual packs. It is sold in 20, 60, and 90 pack containers.
Okay.
And then this is A, B, C, D, and E question.
Okay.
So which container do you think has the lowest unit rate of dollars per pack? Why?
Okay. What was the first part of the question?
Dishwasher detergent is sold in individual packs. It is sold in 20, 60, and 90 pack containers.
They don't give you the individual pack rate?
No.
They give you what the 60 pack rate is or the 90 pack?
No. None.
There's no way to answer the question. And their question is, which one's the better deal?
Yeah, no, which one do you think is the better deal and why?
Oh, well, I hate that question. Because it's subjective.
Yeah,
Math questions are not supposed to be subjective. They're not supposed to require an opinion.
I hate questions like this.
I do too. She shouldn't give them to you. In real life, the larger quantities tend to be cheaper per unit.
Yeah, because nobody wants to buy that much.
Exactly. In other words, if you go to Walmart or Sam's Club or Costco, I guess, where you can buy 100 rolls of toilet paper in one time, you're probably going to get each roll at a slightly cheaper rate than if you went to the grocery store and bought 2 rolls of toilet paper. So in real life, things that are packaged in bulk tend to be cheaper per unit than the other way. But that's not always true, and it's not really an assumption you can make based on just what she gave you. So that's A. 90 is the cheapest, probably. Okay, what's B? Question B?
Oh, and of course, now it gives us
Right,
present.
of course. I knew.
Container sells for $5.49. What is the unit rate in dollars per pack?
Which one sold for $5.49?
20.
Okay. So we have 20, what are they again? Oh, dishwashers. So we have 20 per $549. So how are we going to figure out what one sells for?
You have to find,
what do we want to end up with? We want to end up with, in the numerator, 1 DW. So how do I get that?
dollars per dishwasher detergent.
Hold on, is that what she wants? I thought she wanted to know the price of an individual pack of dishwasher detergent.
Yeah.
In order to determine the cheapest, we need dishwasher per dollar.
Oh,
In other words, I want to divide top and bottom by 20.
okay.
That's going to give me one pack of dishwasher detergent for whatever this price is. What is 5.49 divided by 20? Why don't you do that one on your calculator, just for speed's sake.
Let me get it up. Here we are. Okay. So 5.49 divided by 20. 27 cents about.
So $0.27.
Yeah.
So, in other words, in this packaging, each one costs 27 cents. Okay, so let's write that here. And was 40 the next one?
Yeah. So
How much did the 40 pack cost?
one moment. $10. No, there's no 40 pack.
There's no 40? Okay, what was the next one?
There is the 60-pack container. It sells for $10.97.
97?
Yeah.
Okay, so how are we going to figure out what one of these costs? That means we got 60 DWs per $10.97.
Divide 10.97 by 60.
Okay, so that'll give us 1 DW in the numerator.
You get 18 cents.
$0.18 or 18 cents. So this one is 18 cents per unit. So that's quite a bit cheaper.
Yeah.
And what's the 90 pack sell for?
The 90 pack, $18.95.
Okay. And notice that if I want, I can reverse this. Let me just do it this way for a moment. I'm going to put the $18.95 in the numerator and the 90 dishwashers in the denominator. And guess what? It doesn't matter. Either one's going to give us the answer. Notice I still need to divide top and bottom by 90. Divide 1895 by 90.
21 cents. you get about 21 cents.
Per one dishwasher pack.
So the 60 pack is actually the better.
You're absolutely right. The 60 pack is the better. That makes a lot of sense. Notice that the 90 pack only has 50% more than the 60 pack has. It only has an extra 30. So it should only be priced half as much. So maybe another $5, but they've priced it another $9 or $8 more rather.
Yeah.
So
They cheated.
well, it just made our first assumption wrong. In other words, when we assumed that the 90 was going to be the cheapest per unit, you're not always right with that. I'm glad they did that. Because you can't always assume that that's the case.
Yeah. So the next one is, which container has the lowest rate? How does this compare with your answer in part A?
Okay, so what's the answer to that?
Well, the 60 pack is, and this compares because I was wrong.
Our guess was wrong.
Yeah.
It's another one of those answers I hate. Okay, questions that I hate.
Yeah.
Was there a part D? Or just A, B, and C?
That was part E.
Oh, okay.
Yeah.
Do we do them all? Did we answer everything we needed to?
Yeah.
Okay.
So there's more practice on the Big Ideas Math website if you want to go there.
Okay, we only have like 5 minutes, but that's time to do it. You want to, oh, I have that. I don't need you to open that up here. I have that on my bookmarks, I believe. If I can find it. On Common Core, right?
You're not coming through too great.
My sound? Really?
You're kind of staticky.
Wow. Well, see, the problem is I'm not on my phone. I'm on Google phone, which uses the internet. So sometimes if the internet is the problem, there's no fixing it.
I think Google just fixed itself.
Yeah, the Google phone seems to be a little bit better than GoToMeeting, but they both are transmitting audio by way of the internet, not the phone lines.
Yeah.
So they're both going to be subject to internet speeds. Let's see. I think I have to click on students if I remember right now. This doesn't look right. I don't remember having to put in a password and username before.
So on the left where it says Home Edition, press Go.
Okay. We need the middle one.
Accelerated. And then chapter 3. And then
You got time for 1 or 2 problems. You pick which part you want to look from.
let's do 3.1, the pages 100 up.
Now let's just go down to the exercises here. All right. Shall we start with 7? Oh, we did this.
You did?
No, I guess we didn't. No. No, I thought this was the very first one you gave me because I saw an H. But
Yeah, because I was thinking of doing the homework questions that she didn't give us
okay.
yesterday. So,
So just read these to me real quick. What's this one going to be?
That one's going to be $72.
Okay. What's this one?
That's going to be...
These are easy. Let's do something harder.
So, 29 we never did.
Okay.
27 through 29 never did.
Well, let's start with 27.
So,
Okay. This is kind of like the running problem.
you have, at 1 p.m. you have 24 megabytes of movie.
Uh-huh.
At 1:15 you have 96 megabytes. What is the download rate in megabytes per minute?
Okay. How do we do that?
So, you 96 minus 24.
That's 72. That's 72 meg per what?
Per 15 minutes.
Okay.
And those are both divisible by 3. And it's...
Okay. Let's stop for a moment. She wants megabytes per minute, which means we have to end up with 1 minute in the bottom.
Oh!
Doesn't matter if they're both divisible by 3. That would give us some number of megs per 5 minutes, which isn't going to help. We need per minute. So how am I going to get how many megs per minute?
To divide by 15 on both sides.
Right, on top and bottom. Not both sides, top and bottom. It's different than an equation. It's not the same as an equation. In other words, this is a fraction which I'm allowed to multiply or divide by 1. And that's all I've done. When I divide top and bottom by 15, I'm dividing by 1. So 72 divided by 15, convert that to a decimal.
You get 60, which is 4.8.
Megs
Yeah.
per minute, per 1 minute. And that's what they wanted, was the megs per minute ratio. So whenever they ask for that, know that you have to end up with 1 minute in the bottom. In other words, we could have divided each side by 3, and the top goes to 24 megs per 5 minutes, but that's not the answer they want. They don't want the rate per 5 minutes. They want the rate per 1 minute. So you have to make the bottom be 1 minute, whatever you need to do that. All right, let's stop there. Okay, I guess I will talk to you next Wednesday. That's not Thanksgiving Wednesday, is it? No.
No, Thanksgiving.
No, that's
Wednesday.
1 week later than that, yeah. Yeah, the week of Thanksgiving, you probably, I'm guessing, are not going to need a session that Wednesday.
Yeah.
Okay, you might want to check with your mom before I cancel you out on that date. But I'm guessing that's being the last day that before Thanksgiving you won't have homework or anything. So, but we'll meet once again before then, and you can let me know for sure then. Okay?
Thanks.
Talk to you later, David. Have a good week.
See you Wednesday.